Okay, so 8.1 polar coordinates. So what are polar coordinates? It's another way of describing where something is on like an XY plane. But instead of XY, instead of like XY coordinates, these are polar coordinates. So it's still on this 2D surface and there's still this like origin. Our new origin is called a pole. So that's O for origin and that's called a pole. That's the center. And then how we draw it is we always start with a polar axis. So that's basically like the positive x-axis. So that's the initial ray from the pole to the right. And then how we graph our polar coordinate is we look at r comma theta. So r is our radius, or basically our length from the pole. And then theta is the angle that we're going from the polar axis in this counterclockwise direction. So you know how we were drawing angles before from the positive x-axis and we were drawing counterclockwise? So it's the same kind of idea. So basically on an xy axis, this might be like 1, 2, 3, 2. But instead, we're going to call it this distance, whatever that is, so like a radical whatever, comma, and then, I don't know, 30 degrees or whatever, right? So it's just another way of graphing coordinates. These are called polar coordinates. So r is our directed distance. It's our radius, and it's our directed distance. So there's a distance of a radius and it's in some certain direction based on our angle. Theta is our directed angle, right? It starts from our polar axis and it goes counterclockwise. Okay, so drawing these are very particular. So how would we draw something like this? So let's say we have 3 comma 5 pi over 3. Okay, obviously we're going to need to refer to the unit circle. And you're going to remember the unit circle, but on the back of your notes, I gave you this to remember it and like refresh our memories. So for the first few homework assignments, you're going to use this unit circle, or you can use whatever one you want. But then later, you're going to have to, you know, eventually this needs to be in your brain again. Okay, so I know it's been a while. Okay, so 5 pi over 3. We're going to draw 5 pi over 3 first. Where is 5 pi over 3? Well, this is pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So you're going around this way. So it's this angle over here. So we're going to draw from here all the way counterclockwise and then like that. So that's how we start the angle. So I start with my polar, I always start with my polar axis and I go all the way around to 5 pi over 3. I draw my angle. Here's my angle, like my little arrow for my theta. And then I count out my radius. So 1, 2, 3. Here's my point, and then I call it P for point. So all of this stuff is important to me, and it's important that you have it on your graphs, okay, of your polar coordinates. So let's say you're doing something like this. So where would you start this? Well, you start from the polar axis, and then you draw the angle, whereas negative pi over 4, well, pi over 4 would be 90 degrees up, so negative pi over 4 would be down here. So you draw that angle first, you draw negative pi over 4, wherever that theta is, and then we start counting out. So it might look something like this. So pi over, oh sorry, this is pi over 2, this is pi over 4, so this is negative pi over 4, and then you count out 1, 2. So notice I have my little directed angle, and then I have my P for point, okay? Okay, another one. How about 4 comma 0? 4 comma 0, well, what would be 0 degrees? 0 degrees is right on that polar axis. So on the polar axis, I'm just going to count out 1, 2, 3, 4. You need that P for point. So this is your origin, and this is your point. Really, it's not called an origin, it's called a pole, okay? All right, something like this. So you start with the polar axis, and then you're going pi over 3, and then, see how there's nothing there? So here's my pi over 3, here's my positive pi over 3, and then see that negative 2? So if it was positive 2, you'd count out 1, 2, and put your point here. But negative 2, you have to count out the other direction for your point. That's how you draw negative 2 comma pi over 3. Okay, another one, actually the last one. So maybe something like this. So you start with theta. So how do you draw negative pi over 2? Well, pi over 2 is 90 degrees. So this is negative 90 degrees. So you start with that. So you're drawing this part first. And then a negative 3 as your radius. So 1, 2, 3 going the other way. There's your point. Okay. Okay. And then this one is very interesting, and I really like these questions. Okay. So I'm gonna block off this part first. So it says find 4 equivalent representations of 4 comma pi over 6. Okay, so 4 comma pi over 6. So let me give you an example of, let's say, this one over here. Okay, so this one, I could call this negative 2 comma pi over 3. I could also call it negative 2 comma, if I go all the way around here, that angle would be what? 4 pi over 3, right? Is that right? So actually it would be positive 2 comma 4 pi over 3. So if I went all the way this way, I can call it positive 2 comma 4 pi over 3. So I can keep it the same and go all the way around like a whole circle and use negative 2. Or I can go halfway around either direction and then call it positive 2. So my first thing that I actually want to do is I want to write my negative version. Okay, so my negative version is going to be negative 4 comma, and then if I go halfway around, it's 7 pi over 4. So I just add pi, right, when I go halfway around. So I can either add pi or I can subtract pi. So what I want to do for myself is I want to get one regular version and one opposite version. And then I get my 4 equivalent representations, starting with this and then starting with this. So my first one, I say, okay, I'm going to keep it the same. I'm just going to add pi over 2. My second one, I'm going to keep that the same. And then I'm going to subtract pi over 2. So what's 1 pi over 6 minus 12 pi over 6? It's negative 11 pi over 6. Okay, my third one, actually I already wrote, right? Negative 4 comma 7 pi over 6, sorry. And then my last one, I can use this, and then I can add 2 pi or subtract 2 pi from here. So either way is okay. I decided to minus 2 pi. So minus 12 gives me negative 5 pi over 6. So I decided to draw it over here, and then I wrote a little note for myself. So over here, so you can use the same one and just add or subtract 2 pi, or you can go ahead and change it to a negative and then add or subtract pi. From there though, you're going to add and subtract 2 pi if you keep using the negative 4. So I drew this for you so you can see what it looks like, and I wanted to draw it so you can see these are equivalent. If you're like, Miss Tan, what are you talking about? So these are equivalent. So if I do pi over 6, it's somewhere up here, and then I counted out 4, positive 4, right? So here's my drawing for 4 comma pi over 6. And then what would negative 4 comma 7 pi over 6 look like? Well, I would go all the way to here, and then I would go backwards. See how these are equivalent then? You know what I'm saying? Okay, so I like these a lot. Okay, so the next part is writing polar and rectangular and kind of going back and forth. So here is what I mean. So I'm going to start off with, let's say, so polar looks something like this, right? So if I have a point P and I think about, okay, this is my angle, this is like my x-axis, my y-axis would normally go up and down, but polar like starts with my polar axis, and then I go theta, and then I count out my radius. So here's my r for radius. And then if I kind of like take this and I put it on xy, here's my x, here's my y, right? Okay, so what is sine? Sine, if we look at that right triangle, sine would be opposite over hypotenuse. So y over r, right? And then what's cosine? Cosine of theta is adjacent over hypotenuse. It would be x over r. That's right, right? I'm not crazy? Yeah. Okay. So how can I rewrite these and solve for x and y? Well, if I solve for y, what do? I multiply by r on both sides. If I solve for x, I multiply by r on both sides. So what we have here is something that we're going to use a lot. Y is equivalent to r sine of theta. X is equivalent to r cosine of theta. That is always true when you're changing back and forth between polar and rectangular coordinates. Okay, so we can see in this triangle right here, right triangle, a squared plus b squared equals c squared. So I can write this, right? If I take the square root of the left side, I get the square root of the right side. So I'm just kind of solving for different quantities that I might want to go back and forth later, okay? And then theta. So I have x, I have y, I have r, I have theta, right? So x, y versus r theta. So here's my x, here's my y, here's my r that kind of goes back and forth between r and x and y. Here's, you know, x and then r theta, here's y, r theta. Okay, so now I have theta. So what is true about theta? Well, theta is, I could say, I'm gonna go like this. Tangent of theta is y over x, right? That's true. It's opposite over adjacent. So if I solve for theta, I should be able to say that tangent inverse of y over x is theta, right? If I want to solve for theta instead of y over x. Okay, so tangent inverse. Remember inverses? Remember how for inverses for tangent, you're in quadrant 1 and 4. I know it's been a while, but that is true. How would you get to quadrant 2 or 3? So when we're doing it, like in our heads, we can deal with it and we don't have to worry about this part. But on a calculator, we have to, if we use tangent inverse, they only give you quadrant 1. So if you're in quadrant 2 or 3, remember we have to add pi to get to quadrant 2 or get to quadrant 3. So if we're supposed to be in quadrant 2 or 3, we have to add pi on a calculator. So that's only for if we're on a calculator. Okay, I'll show you how this works. Okay, so let's say we're converting to rectangular coordinates. So I'm going to start first by saying, okay, this is not rectangular right now. So what is this? Is this xy? No, this is not xy because that's what we're trying to get to. Right now, this is r theta. So I'm just going to remind myself, right now we're in r theta. How do you get x? Well, x is equal to that. So x is equal to r cosine theta. R is 3. Cosine of 3 pi over 2, oh, it's been a while. Let's look. 3 pi over 2, the cosine value, the x value is 0. Okay, so 3 times 0, so cosine of 3 pi over 2 is 0. 3 times 0 is 0. Okay, now we're going to go ahead and solve for y. So r sine theta, r is 3. Sine of 3 pi over 2 is negative 1. So you multiply, you get negative 3. Your xy coordinates that match exactly your polar coordinates are 0, negative 3. So if you graph this on a polar plane versus an xy plane, it's in exactly the same spot. Okay? Just like this one, if you graph this one, this is a polar plane. If you graph it in an xy plane, you would get still 4, 0. Okay, so this just happens to be the same polar and xy. These are not, because obviously the theta is really messing with us here. Okay, let's try another one. So again, I'm going to start with r theta, and then I'm going to start with my x. So r cosine theta, my r is negative 4. Cosine of negative pi over 4 is positive root 2 over 2. You multiply that together and you get negative 2 root 2. And then r sine theta, you multiply, you get 2 root 2. And then you have your rectangular coordinate. So this is an xy value, okay, xy point. Okay, what if you go backwards? All right, this is actually the easy way. So going backwards to polar, so you have to think about this. That's why it's a little trickier. So the first part's easy, the second part's tricky. The theta is going to be tricky. Okay, so 2 comma negative 2. Right now we're not in polar because it says convert to polar. So this is an xy. So the first thing we're going to find is r. So how do we find r? Right here we have a formula. So I just wrote that one time, even though I probably wouldn't write that normally. So I wrote it once, and then I just square the 2. I square the negative 2. What is that? It's 2 root 2. Okay, I'm going to keep going. All right, so now I'm going to try to find theta. Theta is tangent inverse. And then we're going to, this is where we really have to use our brain power, okay? So tangent inverse of y over x, which is tangent inverse of negative 1. You're thinking, where do you have a tangent of negative 1? Tangent of negative 1 happens here and here. These are our two places, 3 pi over 4 and 7 pi over 4, right? Because that's where when you divide, you get a negative 1, okay? And what quadrant are we in? We're in quadrant 4. How do I know we're in quadrant 4? Because literally this is a positive comma negative. So if you're positive negative, you're going to the right and down. That's quadrant 4. All right, so which one is it? Is it this one or this one? Right here, you're in quadrant 4. This is 7 pi over 4. We really need to remember this unit circle again. Okay, so that must be 7 pi over 4. And then we write 2 root 2 comma 7 pi over 4. So there is our r theta. Okay, another one. Let's say you have this. And then again, you're telling yourself what quadrant you're in because you need that later for tangent inverse. Okay? So then this one, you're going to start with r. And that you just like square, square, and you go, oh, that's root 4. That's 2. Okay, no problem. All right. For tangent inverse, you're thinking, oh, this has been a while, right? Okay, so sometimes it's actually helpful to think about, well, what is tangent? What did that come from? What did that come from? So how about this? How about sine over cosine, right? Didn't this come from root 3 over 2? Didn't this come from 1 over 2, right? This doesn't actually exist on a unit circle, but this one does. So in quadrant 3, where would you have a y value that's root 3 over 2 and an x value that's 1 over 2? So in quadrant 3, y value, x, 4 pi over 3. That's why here I wrote 4 pi over 3. So you have to really think about it, okay? All right, final answer, 2 comma 4 pi over 3. So r comma theta. Okay, the last one for these, I'm thinking, so here's my xy, I'm in quadrant 2, so this is negative comma positive, so left up, so quadrant 2, okay. So then I find my r, and I get root 17, and then I plug in, and I try to find my tangent inverse, and I think, and I look at my unit circle, and yeah, that doesn't exist on the unit circle. There is no negative 4 over 1, right? So this is a calculator issue. Okay, so I plug it into my calculator, and then I realize I want to be in quadrant 2. Is this in quadrant 2? Nope. This is in quadrant 1 or 4, because the calculator only gives you basically quadrant 1. Okay, or 4, yeah. So this is in 1 or 4 because it's negative, it's in quadrant 4, okay? So what do? We add pi. So when you add pi, you get 1.8 something. And then, so in your calculator, you actually add pi. And then your final answer is root 17, comma 1.82. Okay, last part on the back. You're converting equations. So I actually really like these. So converting to rectangular equations, so what you have in the beginning is, there we go, is r for sine theta. So your goal, okay, your goal for rectangular is no more r's, no more thetas. So you have to somehow change this into x's and y's. So you want to think about this and you want to be like, okay, what should I see? So if there was an r next to the sine, I would be really happy because r sine theta is y. So let's do it. Let's multiply r on both sides. So if you multiply r on both sides, you get this. And then, can't you change this? What can you change this to? X squared plus y squared. What can you change this to? 4y. So then you do that. And then I'm going to say, as a final answer, anytime you're doing rectangular equation, let's go ahead and say that answers should equal 0. So we're going to keep going until we get equal 0. So I'm going to say that is a totally fine answer. I want to show you something. I want to just remind you of something. Is it going to come up a lot? No, but this can look different. Let's say it's a multiple choice question. This can look different because if we try to complete the square, then we can get this as an answer as well. Okay, so just realizing that this is equivalent to this, but in general, yes, for rectangular equation, we're going to end here. We're going to end where it equals 0. Okay. Okay, a little bit of different rule for converting to polar. So converting to polar means no x's and no y's. All right. So it starts with x equals 4. So you're like, wait, what? So that's okay. What is x? X is r cosine theta. All right. So the answer, instead of equal 0, we're going to say that in general for polar, we're going to go ahead and solve for r. Okay. Does it have to be like this? It's not necessarily, but again, when I give you multiple choice, my answers are going to equal 0. And they're going to say r equals, or sometimes r squared equals, r cubed equals, whatever, okay? So my polar, when I change it into polar, I'm going to have an r equals, all right? So you're going to have to switch it around. Oh, and how did this come up? Well, when you divide by cosine, 1 over cosine is secant, right? Okay, so the very last one, another one of these. All right, x, y, what are you going to do? So change the x, change the y. What is x? It's r cosine theta. What is y? It's r sine theta. Let's write it down. And then you get equals 25. Okay, we're going to keep going. Let's see if anything weird happens. We get this. All right, some of you might be like, oh, okay, we're going to be done. We're going to go ahead and divide the 4. We're going to divide the cosine and sine. But maybe there's no answer that looks like this or anything like this with cosine and sines. And maybe you're going to see something that you have to recognize as this first. So I split up the 4 into a 2 and 2. This should look very familiar even though it's been a long time. This is a double angle formula for sine. All right. Now you can solve for r squared. You can divide by 2 and divide by sine. What's 1 over sine? Cosecant. So this would be one of the answer choices you would find in any sort of multiple choice. And you know what I won't do to you? I will not say none of these because otherwise you're not going to pick this, okay? So you'll have 4 or 5 answer choices and the other ones will be wrong. They're not going to be right. It's not going to be like this one and this one. No, it's going to be this one and then other ones that are incorrect, okay? So there you go. Here's 8.1. Try your best. Good luck. Ask each other questions. All right.